Hello BSc students. In previous video we have learned how to find the rank of a matrix and how to reduce the given matrix to an echelon form and how to use the elementary row transformations. Okay, and in today's video we are learning how to reduce the given matrix into normal form. Okay, so here before reducing into normal form, first we reduce this to echelon form. Okay, and then only you will reduce it to normal form. Okay, so here see we are having first row first element as 1, and here we are having 1 and 1 below this, so we will make this and this 0 using this 1. So what is the transformation? R2 changing to R2 minus R1 and R3 changing to R3 minus R1. So if I use this transformation, A is now equivalent to 1267, as there is no transformation for row 1, and R2 is changing to R2 minus R1. So it is 1 minus 1, 0, 3 minus 2, 1, 4 minus 6, minus 2, 5 minus 7, minus 2. See, and when we move to the third row, the transformation for that is row 3 minus row 1. So it is 1 minus 1, 0, 5 minus 2, 3, 0 minus 6, it is minus 6, 1 minus 7, minus 6. And now, in the second step of the echelon form, we'll move to second row, second element. And here it is already 1. And using this, we'll make this 0. So, we'll make this 0 using this. And for that, the transformation is R3 changing to R3 minus 3R1. Why? Because we are having plus 3 here. So, it is minus 3R1. So, now A is equivalent to 1267, 0, 1 minus 2 minus 2. And now for R3 it is R3 minus 3, sorry, it is R2. Okay, so it is 3 minus 3 into 1, that is 0, and here it is 0 minus 0, it is 0, minus 6 minus 3 into minus 2, so it is minus 6 plus 6, 0, and same here 0. So here we have reduced the given matrix to echelon form. And now how will we reduce this to normal form? Now we'll use the column transformation. Okay, see here, when we reduce the given matrix to echelon form, we use the row transformation. But here, when we are reducing the echelon form to normal form, we are using the column transformation. And here, at last, in normal form, at last you will be having the elements of the matrix as 1 or 0. So, there should be no other elements like 2, 6, 7, minus 2, minus 2. Okay, there should be either 1 or 0. So here what I will do is, I will make this 2, 6, 7, 0 using first column. So it is very much similar to row transformation. Here we made this and this 0 using first row. Okay, that is using first row, first element. And here what we are doing, we are making this 2, 6, 7, 0 using this first column. Okay, so here the transformation will be column 2 changing to column 2 minus 2 times column 1, because we are having plus 2 here. So it is minus 2 into column 1. And next C3 changing to, because it is column 3, C3 minus 6C1. Okay. And next C4 changing to, we are having plus 7. So it is C4 minus 7, C1. So now our given matrix is equivalent to, see, we don't have any transformation for first column. So I will write that as it is. Okay, 1 0 0 1 0 0. And for second column I am having C2 minus 2 C1. So it is 2 minus 2 into 2, that is 0. 1 minus 2 into 0, that is 1. Next, 0 minus 0, that is 0. Next, we'll move on to the third column. So, we'll use this transformation. C3 minus 6 C1. 6, C3 is 6. C1 is 1. So, it is 6 minus 6 into 1, that is 0. Next, C3 is minus 2. C1 is 0. So, it is minus 2. Next, C3 is 0, C1 is 0, so it is 0. Okay. Next, we'll move on to fourth column. So we'll use this transformation, that is C4 minus 7 C1. That is C4 is 7, C1 is 1. So it is 7 minus 7 into 1, that is 0. Minus 2 minus 7 into 0. C4 is minus 2. C1 is 0. So it is minus 2 minus 7 into 0. That is minus 2. Next it is 0 minus 7 into 0, which is again 0. Okay. So this is the first step after reducing to echelon form. So this is the first step once the given matrix is reduced to echelon form. Okay, and now moving on to the second step, we'll move to second column, second element, and we'll make this and this 0 using second column. Okay, so here the transformation will be for C3 and C4, because this is in C3 and this is in C4. So C3 will now change to C3 plus 2C2. Why? Because we are having minus 2 here, and since we are in the second step, I am using C2. Okay, because I am using this. Okay, so now C4 is C4 plus 2C2. Why? Because we are having minus 2 here. So it is plus 2 into C2. Okay. So now our given matrix is equivalent to, there is no change for first column, no change for second column. And now the third column is C3 plus 2C2. C3 plus 2C2 is 0. Next, C3 is minus 2, C2 is 1. So it is minus 2 plus 2 into 1, that is 0. Next, 0 plus 2C2 is 0. So it is 0. Next, we'll move on to fourth column. Okay. So it is C4 is 0. C2 is also 0. So it is 0. Next, C4 is minus 2. 2C2 is this one, 2 into 1. So it is again 0. C4 is 0, C2 is 0. So it is 0. And here you can just see we are having the entries of the elements as 1 and 0. That's it. There are no other elements other than 1 and 0. So now the given matrix is reduced to normal form. Okay. So I can write this is equivalent to this, because I am having 1001, which is similar to this I2. I2 means identity matrix of 2 cross 2. Okay. And now here and remaining side we are having 0. So here we are having 0. So you can either write this or this. And now we are having two non-zero rows. So therefore the rank of A is 2. Okay, so this is how we'll reduce the given matrix to echelon form. Okay, Now we'll move to next problem. A is equal to 1, 1, 2 minus 3, 4 minus 1, 0, 2, 0 minus 3, 0, 4, 0 minus 1, 0, 2. Okay. And here, first we'll reduce the given matrix to echelon form and then to normal form and then find the rank of a matrix. Okay. See here, for me to reduce this given matrix to echelon form, the first step here is we need to move to first row, first element, and below that we need to make this and 0. And these two are already 0, so I am left with only this one. So I need to make this 0 using this element. Okay, so for that transformation will be row 2 changing to row 2 minus 4r1. So now our A is equivalent to 1, 1, 2 minus 3, 0. Because 4 minus 4 into 1, that is 0. Next, minus 1. R2 is minus 1. R1 is 1. So it is minus 1 minus 4. That is minus 5. 0 minus 8. So it is minus 8. 2 minus 4 into minus 3, that is 12. So 2 plus 12, 14. And remaining thing is written as it is, as there is no transformation for R3 and R4. So this is the first step. And now in the second step, I need to make this one. Before that, I will check whether other rows are having 1 or not. And here I am having minus 1. So what I will do is, I will just exchange this row with this row, so that I will get minus 1 here. Okay. So what I will do is, I will just exchange R2 with R4. And for exchanging, I will write a double-headed arrow. Okay. So now the given matrix A is equivalent to 1, 1, 2 minus 3, 0 minus 1, 0, 2. So here I am writing this R4 here. As I am interchanging R2 and R4, I am writing this in R2 and this in R4. Okay. So next column is, next row is 0 minus 3, 0, 4. And next one is 0, minus 5, minus 8 and 14. So now we'll start the second step. Okay. See here I am having minus 1. So I will make this and this 0 using this one. So R3 is changing to R3 minus, see here the minus 3 here and minus 1 here. So what I will do is, I will subtract. Okay. R3 minus 3R2. So if I do this, R3 will be minus 3. Minus 3 into R2 will be plus 3. So this becomes 0. And now similarly R4 is R4 minus 5R2. Okay. And now therefore, see here, the given matrix is now equivalent to 1, 1, 2 minus 3, 0 minus 1, 0, 2. Now R3 is R3 minus 3R2. So it is 0 minus 0. Minus 3 into minus 1. So minus 3 plus 3 is 0. 0 minus 0. 4 minus 6 minus 2. 0, now we'll move to row 4. So it is R4 minus 5R2. 0 minus 0. 0. Next minus 5. Minus 5 into minus 1, that is minus 5 plus 5 is 0. Next it is minus 8. Minus 5 into 0 is minus 8. Next 14 minus 5 into 2, that is 10. 14 minus 10, that is 4. So now let's move to third step. Third step means third row, third element. and here we are having 0. So what I will do is I will exchange this with this row so that I will get a non-zero number here. Okay, and below that I'll be having 0. Okay, so if I do that, that is R3 interchanging with R4, if I do this, I will get A is equivalent to 1, 1, 2 minus 3, 0 minus 1, 0, 2. Now if I interchange these two, 0, 0 minus 8, 4, 0, 0, 0 minus 2. See here, and now the given matrix is in the echelon form. Why? Because see here, first row, first element, the elements which are below this is 0. Second row, second element, the elements which are below this is 0. Next, third row, third element, the element which are below this is 0. Now, fourth row, fourth element, there are no elements. So, we'll stop it here. Means, we have reached the echelon form. And now, what we'll do is, we'll now move on to normal form. And in the normal form, we'll make this 0. Okay, so we'll make this 0. So, for that, the first step in normal form is we'll make this and 0 using first column. So the column transformation is for C2, C3 and C4. Okay. So C2 is changing to C2 minus C1. Okay. And C3 is changing to C3 minus 2 into C1. C3 minus 2 into C1, and C4 is changing to, see here we are having minus 3, so it is plus 3 into C1. So C4 changing to C4 plus 3 into C1. So if I use this transformation, A is equivalent to, I don't have any transformation for first column, so I will write as it is. And now C2 is minus 2C1. Okay. 1 minus 1, 0. Minus 1 minus 0, minus 1. 0 minus 0, 0 minus 0. Next, C3 minus 2C1. 2 minus 2 into C1. That is 0. 0 minus 0. Minus 8 minus 2 into 0. 0 minus 0. Next, C4 is C4 plus 3 into C1. So, minus 3 plus 3 into 1, 0. 2 plus 3 into 0. 4 plus 3 into 0. Minus 2 plus 3 into 0. So, we'll get like this. Okay. And now, we'll move to the second step. In second step, we'll go to second column, second element. First, we'll make this 1 because in the normal form, we need the elements only 1 and 0. Okay, there should be no elements other than 1 and 0. So, what I will do, I will divide this column by minus 1 so that I will get 1. Okay, C2 is changing to C2 by minus 1. So A is equivalent to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, minus 8, 0, 0, 2, 4, minus 2. Okay. So now in the second step of the normal form, we'll move to second row, second element, and that is 1. And here we'll make this and this element 0. But this is already 0. So we'll make this element 0 using C2. So the transformation will be for C4 and C4 changing to C4 minus 2C2 as we are having plus 2 here, minus 2 into C2. Okay. So now our A is equivalent to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, see here, minus 8, 0, And now the transformation is for C4. 0 minus 2 into 0, 0. 2 minus 2 into 1, 0. 4 minus 0 is 4. Minus 2 minus 0 is minus 2. So this is the second step. And what about the third step? And here in third step, we'll make this 1. Because in third step of the normal form, we are moving to third column, third element. So here we are having minus 8. So we'll divide this column by minus 8. So here C3 is changing to C3 by minus 8. So our given matrix is now equivalent to 1 0 0 0 0 1 0 0 0 0 1 0 like 0 0 4 and minus 2. Okay, and now here we have made this one and will make the element 4, that is beside this element, as 0 using C3. So the transformation for that will be C3, sorry, this in fourth row, so sorry, fourth column, changing to C4 minus 4C3. So this is C3 because we are in the third step of the normal form. Okay, so it is C4 minus 4C3. Okay, see, if you are in the third step of the echelon form, we'll use row 3. If you are in the third step of normal form, you'll use C3. Okay, so there in echelon form, you are using only rows, and here in normal form, you are using only column transformation. Okay, and now the given matrix A is equivalent to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 because C4 is changing to C4 minus 4 C3. So it is 0 minus 0, 0 minus 0. Next 4 minus 4. So it is 0. Next minus 2 minus 0, that is minus 2. And now we'll move to the fourth column, fourth element. And here it is minus 2. So what we'll do? We'll divide this column by minus 2. So the transformation here is C4 changing to C4 by minus 2. So therefore, A is equivalent to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So this is the normal form of the given matrix, and since we are having 4 non-zero rows, rank of A is 4, and we can write till here, or also we can write this as I4. Okay, since we are having identity matrix of 4 cross 4 order, I can write this as I4. Okay, so this is all about the normal form. Okay, in next video we'll start up with Cayley Hamilton theorem. Okay, thank you.